Okay. So, what's a differential equation? Differential equation is ultimately a rule that relates derivatives of a function to the function. Okay, where you know things about rates of change and you're trying to recover the function from the information you have. So, I'm not going to tell you what a general differential equation is, but first order equation. Okay, differential equation can be lots of things. A first order equation is of the form y prime equals f of t y. Okay? We know that y prime is a derivative, right? So you have a function of two variables, t and y. Y is a function of t. Okay, so y is a function of t, and we want to find our function y of t. So anytime I write a y, it's really a y of t, but I don't want to, it gets complicated to look at if you keep putting the t in there. So implicitly, y is a function of t. Of course, it could be a function of x and t also. This function could be a function of x and y, so y would be a function of x, okay? You'll see a little more here in a minute, okay? So let's just take let's see one that has a reasonable picture. Okay, equals t times the square root of y. Now we can solve this very easily. But I'm going to use it as an illustration because it's very easy to write down equations that just can't solve. Okay? So we've got y prime equals t square root of y. And we're going to say that y of 0 equals, let's say -1. Okay? Well, what does y of 0 equals -1 mean? It means when t is 0, y is -1, right? Sorry. I don't want that equal -1, I want it equal 1. Okay, y of 0 is now 1, okay? When y is 0, when t is 0, y is 1. Well, when t is 0, y is 1. What's that tell you about a graph of y versus t? Pretty obvious. Again?
Y is 1, t 0.
And what can you do with the graph then?
Graph that point.
You can plot that point, right? Gives you a point on the graph. Okay? So, when t is 0, y is 1. So when t is 0, well, that puts you on the y-axis, and now y is 1. So we're going to put the point 0, 1 here. Okay? Now, y prime equals t times the square root of y. So, what does that tell you? First of all, what's the geometric meaning of y prime? What's the derivative of a function tell you?
Change.
It's the rate of change. And graphically, how's that appear?
It's positive, it's increasing, if it's negative, or if it's above
Why?
0, it's increasing. It's
Okay, well, why would that be? I'm dragging it out of you.
Yeah.
Yeah. Okay. Well, let's just put a scale on this. Let's say this is 1 and this is 1. Okay? Can you estimate the derivative at this point? It would be the rate of change. So what's the derivative associated with on a curve? When you take calculus, you lose the forest for the trees. Everybody does. Okay? The very first concept of derivative is this help?
Slope.
Huh?
The slope.
Yeah. It's the slope of the tangent line, right? Now, this is what bothers me about either calculus courses or calculus students. And it seems to be universal over courses. That's entirely fundamental. But people don't seem to know it after having had a year of calculus. Okay? I know you guys had good calculus courses, but you're so busy doing the algebra of it, you forget the meaning of everything. Okay, so we really have to get the meaning. And you probably ought to review the first week of calculus. The definition of a derivative, all the concepts. Go back to your text. You got your textbook? If you don't, I'll print you one.
Okay.
A good one. And there's an online text. Okay? And refresh yourself on what these things mean. Otherwise, I don't care right now if you know how to take the derivative of t square root of y, or the differential. You know what a differential is?
I think so. I hope.
Probably not. I'm not going to put you on the spot right
Okay.
now. Okay? Just statistically, probably not. If you don't know that, if you didn't immediately see
What is it, 1 over x? It is square root. Okay,
differential, differential,
What
it's
was-
related to this picture. Okay?
Oh, okay.
And almost nobody ever knows it. So statistically, if you don't know that that's a slope, then you probably don't have a clue what a differential is.
Okay.
But you did it. So how did you do it without knowing what it means? Okay? I know you got good teachers. I know both your teachers, calculus teachers. One of them going to be across the hall teaching us calculus at 11 o'clock. Okay? But you don't know this. Okay? Well, it'll come back to you, but it's got to come back and stay this time. Okay? It can't come in and go away after the test. And one thing you need to develop, and it's an ongoing process. You're not learning for the test, you're learning for the rest of your life. You're learning for your field, okay? So you gotta put things deeper into your consciousness, into your brain, okay? And I say, I had A students last semester in my physics, that same thing. Okay? So there's nothing unusual about it, so don't feel bad, just hustle and fix it. Okay? So I'll be often telling you things that you should know But as with 90% of people who come out of calculus courses, you don't, okay? Because you're too busy jumping through hoops. And they're big hoops, you know. Actually, little hoops are hard to jump through, okay? So anyhow, okay, there it is. Now, back to this. And this is one reason, of course, that what I'm telling you here doesn't immediately click, isn't immediately obvious, okay? But it's not difficult if you understand that the derivative, which is what y prime is, this is just a rule for calculating slopes, okay? So that's a profound enough statement. I'm so proud of it that I'm going to write it down. What did I just say? Can I write it down? That's a derivative. Okay, I put this in a different color over here because it's something that, again, theoretically you would know, okay? Practically, seldom happens. So again, don't feel bad about it, but fix it, okay? Okay, derivative can be thought of as a rule for calculating slopes or rates of change. Okay, so now we're back over to the graph. So what can you tell me about the behavior of y in the vicinity of this point? If we move a little bit to the right or left, well, this tells you something. Tells you what the slope is. Okay? What's the slope? Again?
1.
Don't think so.
T squared of y.
I'm sorry?
T squared or T times square root of y.
Just a little louder. I've got a little hearing loss.
T times square root of y.
Okay, well, but
Is
you
that-
got a point there, 0, 1, right?
Yeah.
So at the point 0, 1, what's t times the square root of y?
Y?
No.
Okay.
You're listening to Wes. Don't listen to Wes.
I'm sorry.
Don't listen to Wes. He's worth listening to. He's a good guy and he's a smart guy. Okay.
Ouch. It's not changing, right? It's just 0 because 0 times 1.
Yes. Yeah.
So,
This is 0
okay.
because t is 0, right? Okay. This means that there's a curve, some curve here, and it's the curve that represents the function, the solution function. Okay? And at this point, that curve is level because its derivative is 0, right? Because y prime is 0. So this curve is level. I can draw this here. Okay? Now, before I go on, I'm going to do direction field. It's not what I was going to start with, but I think it's a good idea now to see what you're understanding or not. Okay, so it should be clear then that everywhere on the y-axis, the slope's going to be 0. The slope of any curve that is 0 as it goes through the y-axis. Okay? Why is that? If you don't know how to answer, pick another point on the y-axis. Give me the coordinates of another point on the y-axis.
This is always going to be 0 on the y-axis.
I just asked for one point. You gave me a generalization,
Yeah.
which would
Yeah.
answer the question, but
Yeah.
let's go a step at a time. Give me a point.
0, 2.
0, 2.
Yeah.
Okay, so at the point 0, 2, And I'm gonna do this in a different color, because I want to use the same color. Okay, well, what's the value of t, what's the value of y?
0 is t.
T is 0, y is 2, right? So when you multiply them, you get
0.
0. Okay, we're seeing y, can we now generalize to the whole y-axis? Anywhere in the y-axis, t is going to be 0. That's a connection you got to make, and if you're not used to looking at graphs that way, well, it's easy to get used to it. So you want to do that, but I can just draw a bunch of points on the y, a bunch of segments on the y-axis that indicate that my slope is always 0. Okay? Now let's go out to t equals 1. So let's just say 1 is here. Okay? Then let's go up to the point 1, 1. Okay, so here's the point 1, 1, right? So I'm not going to label that because it's going to get kind of messed up, okay? Now it's going to get complicated. And there are things I'm going to want to do in the vicinity of this point. However, at the point 1, 1, what do we get?
1.
And what's our slope going to look like there then?
Would it be positive?
Yeah, well, it's going to be 1.
Well, yeah,
right?
going upwards.
So how are you going to draw a slope of 1 on this graph? Well, it'd ordinarily be at a 45-degree angle if a unit here is equal to a unit here on the scale, but this one is a lot bigger than this one, right? So if we went over 1, we usually won't go that far. If we go over 1, we'd have to go up 1, and 1 is a lot bigger here, so it'd be kind of like this. That's what a slope of 1 would look like the way I've scaled this graph. Okay? Now if I'd have put 1 out here, then the slope would look a lot smaller. Okay? And, you know, when you're doing graphs of things, there's no reason to expect that your t scale is going to equal your y scale. If you're plotting the value of an investment where you start with $10,000, at 1 year, 2 years, 3 years, 4 years, you don't want to use the same scale here that you use here because your points would be up in the stratosphere, right? Well, they should be up where there are clouds, because there are clouds everywhere today at the ground and up. But, okay, does that make sense? Okay? So, at 1/2, what would be the slope? It would be 1/2, right? So it'd be half as much as this, okay? So if you went over a unit, you'd only go up half as far, so your slope would look more like this, right? Okay? And then as you go over, well, we could look along this whole line here, okay? Your slope is going to get progressively steeper. Now, I'm not going to try to make this accurate in any sense, but the slope is going to get very steep. It's never going to actually be vertical. But on the scale of this graph, it's going to do something like this, right? So we understand how that can work? Okay. So now, if we go to this, let's just say this is a point where y is 1/4, okay? Or actually, I'll just draw a line here. This is a line y equals 1. This is a line y equals 1/4. Okay? So on this line, what's the slope at this point?
1/2.
It'll be 1/2. Because this point is pretty implicitly, but you know, 1/4, right? So the square root of 1/4 is a half. Multiply that by 1, you get a half. So the slope's going to be about the same as this one, because remember that one was 1/2. Whether you remember or not, believe me. But test, you know, believe and verify, because I make all kinds of stupid mistakes. Okay? Okay? At 1/2, the slope would be 1/4, right? I mean, at this point here, the slope would be 1/4. That'd be something like this. And then the slopes do get steeper, but they're not as steep as they are up here. Now you could also look along this line, which is the line where t equals ½ right? So you get up to 2, well, the square root of 2 is about 1.4, half of that is 0.7. So you could sketch a slope here somewhere between this one and this one. I'll do my best. Okay? So the slopes are getting greater and greater as you go up here, and they're getting greater and greater as you go out here. Okay? Now, if you start at any point, and let's just start a curve. Got all kinds of fancy colors here, but where are they all? Come on, come out of there. Okay. Okay, if I was to start a curve right here, the curve would pretty much follow this line segment. Okay? But as you move to the right and up, it has to get steeper. Because by the time you get out to this point, it's going to be somewhat steeper, right? And now you're out to this point, and well, that's, you know, slope's getting bigger for this way, and slope's getting bigger this way, it's going to be even steeper. So you're going to have a curve that might look something like this, keeps getting steeper. Okay? Well, this is an approximate solution curve. It's an approximate solution curve for the initial condition. You don't have to write that down, but you'll see that, so you've heard it. Your brain's starting to work with that idea. Y of 0, sorry, y of 1/2 equals 1/4. Okay? Because t is 1/2, y is 1/4. We'll just say that this is 1/4 here. Okay? Now, we're wanting the solution for this. Well, we can now see what's going to happen as we start moving to the right where the slope is 0. Well, instantly, our slope is no longer 0 because t is no longer 0, right? Still pretty small, but we're starting to get a positive slope. So we're going to get something that looks like maybe this. Okay? Looks a whole lot like this. But it gets steeper faster because you start out higher. Okay? Get the idea? You can do this. Now we can calculate this approximately. Okay? So we'll go on with that. I'm going to stop this video because it's already long enough.